Yes, please. So we have 20 minutes for that, all right?
Can I run the voice?
Yes.
Yesterday, Fulo and I had a bit of a
Segment
disagreement. I will go for that one. Suppose we have two dice. So suppose we have suppose we have dice A and it has 3 sides, and dice B and it has 3 sides. And omega of A is 1, 2, 3, and omega of B is also 1, 2, 3, for simplistic sake. So suppose we want to get that dice A plus dice B, so the side A and the side of B, suppose equals to 4. So suppose, so we can do the following thing. We can draw a table, say here A, here B, do something. So suppose A and B, so we can do the following thing, and then 1, 2, 3, and here it's going to be as well 1, 2, and 3, right? So here we can check. So 1, 1 won't work, 1, 2 won't work, 3, 1 will work, 2, 1 won't work, will work, won't work, will work, won't work, won't work, right? So we can do this. There's going to be 0.33. Everything is going to be 1/3 probability. Therefore, the answer should be 3 multiplied by 0.33 squared.
1/3? No, 1/9.
No, so to get, yeah, of course 1/9, but to get here is 0.33, and to get here is 0.33. So is this multiplied by this and 3 times like this? So,
yeah.
So my question is, so there's, I don't know if it's the correct way of doing it, there's, instead of doing this graph and wasting my time, is it fine in the test if I just do right sum lambda, whatever this is, plus this, equals to, we want to get 4. This is a member of A, and this is a member of B, and saying the probability of A1 plus probability of B, will this be sufficient as an answer instead of doing all of this? Because this in retrospect is going to be equal to this, and then this, and then this word. Because this one just describes this whole process.
Yes, but how are you going to find this? So you're saying we have omega 1 and omega 2, right? So their sum is 4, and that's it.
So this is going to be, what is going to be equal? It's going to be equal to the probability.
No, and not the sum, by the way. Why the sum?
Well, so why did I say sum? So it's going to be the sum of this plus this plus this, which gave us 3 to the 0.33. So it's going to be equal to the probability of 1 multiplied by probability of 3 plus probability of 2 multiplied by probability of 2 plus probability of 3 multiplied by probability of 1.
Yeah, this is true, but how are you getting this from here? I don't get it.
Well, we know that we're looking for this and this. We know this is a member of this.
So you fix this one. You fix this.
Yeah, so this is always going to be a member of this set, and this is going to be a member of this set.
Okay.
And the most important thing that this plus this have to be equal to 4.
Yes.
Therefore, the probability of this, which is a member of A, plus the probability of this, which is a member of B, has given us the same answer, which gives us 3 multiplied by 0.33 squared.
This is good. This is correct. I don't see why this. Oh, sorry. Why this is equal to this?
Well,
you have look. You are this plus this, and you are multiplying this plus this and this one.
Well, we're looking at such things that are going to create a 4. So this creates a 4, this creates a 4, and this creates a 4.
Yes. So you don't have to write like this. You have to write it in a different way. You have to write it like this. You have to write probability such that omega 1 and omega 2. Wait. And so if we have that omega 1 plus omega 2 is 4, then we can express omega 1 as sorry, omega 2 as 4 minus omega 1. So this omega 2 is that what you are going to write here. So 4 times minus omega 1. This is what you have here. This is this. I don't see why this is this. That's my only question. But this is this. I mean, this is good.
In a programming standpoint, like suppose if we have like A is 1 million, B is like 1.5 million, when I get 500,000 here. So like too much to calculate. So this is like a general formula that you can code up. So
but why sum? You have to multiply them.
Oh, yeah, sorry. Sorry. Multiply. My bad. So
all right. That's a different thing. Yes, of course.
This is right to say if it's multiplication.
Yes.
Okay, thank you. So if
yeah, but you know why? Because we have the intersection here.
Yeah, of course.
And the intersection is just the product, right?
Of course.
Omega 1, and here you don't have omega 2. You have 4 minus omega.
Yeah, of course. Yeah.
Yes.
But if this is if this is multiplication, then it's fine. The right answer.
Yes.
I told you, Pulo. What you tell me? No, the correct answer. Arrest my case.
Yes.
Can you solve 5, 6, and 7 of this one?
5, 6. We don't have time for that. It takes one seminar, complete seminar, for doing that.
I don't think so. So since,
yes, that's a long exercise. I mean, we did it already.
5 and 6 we didn't.
We didn't. No. Yes, we did it.
Did we?
We did 5 and 6. We did it. I can check right now. I'm 100% sure that we did it. Let me see. Okay, so what did we do the last seminar?
No, this is seminar 6. So.
Yeah, let me. No, even before.
Yeah, it's way before. So you can check lecture 7. That's when we did this seminar for this topic.
Let's see. I remember that we did it even here. We did it here, yes. This is lecture 8.
Lecture 8, sir?
Yes.
We only have looked until lecture 6 or 7. We haven't looked. Yes, sir, because you said
what?
Lecture 1 to 6. Is it in lecture 8?
I say homework. I didn't say lecture.
Oh my god, yeah.
Let me see. Somewhere here it should be.
Okay, so for the last one, what's the idea of solving it if we are multiplying the...
You don't need that right now for the test. Okay. So, but we did 5 and 6. We solved it here. Actually, you did it. You solved it.
I solved 4.
You solved 5.
4. No, I solved 4. I remember I was doing something with here.
And you solved 5 as well.
I solved 5?
Yes.
Sure, I solved everything. So, but
it is. I wanna. Okay, let me see here.
Okay, so let's do like this. If
1 more week, sir.
If we didn't solve it, everybody plus 0.5.
I know that you solved
it. If we solved it, minus 0.5 for Rohan, sir. Let's do that.
What do you think that we didn't solve it? We solved it. I mean that is even worse because it means that you haven't checked the lectures here. Just a second. Okay. Lecture 8. Yeah, let's see.
Okay, so what's the idea?
I see. We solved it, but it wasn't recorded. Yes. Sure. That's not my fault. Yes, of course. And I told you, by the way. Yeah, I didn't tell you. I don't know. The deal is that we did it, but for some reason it wasn't recorded. That's not my fault. Well, let's see. Which one? Right. Let's see which one. So we still have like 20 minutes, so okay, where is that? Okay, so for example, D, this is D or this one? So this is homework 6, right? Homework 6, 5B. Let's do that one. What test? This test? Of course not. No. That wouldn't be too easy. So look, we have, what do we have? We have that, so xi is a random variable with distribution, with exponential distribution and parameter lambda, right? And we are given with the random variable eta, which is equal to 1 minus e to the minus lambda xi. Yes, and we need to find the density of eta, right? That's it. So how do we find the density of eta? We just need to find the CDF of eta, right? It means we need to find the probability that eta is less or equal than y. So we replace eta, so the probability that eta, in this case eta is 1 minus e to the minus lambda xi is less or equal than y, right? Now we need this xi to be alone here, right? And we need all this function to be over here. So it means that we need to find the inverse function of this. So how do we find it? If we have 1 minus e to the minus lambda xi, and this is equal to eta. So let's find, no, not eta, it is not a good, to y. So how do we find xi in terms of y? So we have then y minus y, here we have e to the minus lambda xi, right? Then we have to take the ln of 1 minus y, and here we get minus alpha xi, right? And then this alpha has to be divided here, the ln of 1 minus y over minus alpha, and this is xi, right? So this is the function that we can express in terms of y for xi. So this is equal to the probability that xi is less or equal than minus the minus ln of 1 minus y over alpha, right? And now what is this? This is just the CDF of xi, right? So this is the CDF of xi on this point. So this is f of xi in this point, in the point minus ln. Wait, if we have minus here, then we have to change this, right? So look, we had here minus, and then we put minus over here. So it means that we have to change this, right? So if we have less or equal, then we need greater or equal. Yeah? And then this is what? This is 1 minus the CDF, right? well, not exactly the CDS because we have less, greater or equal. Then we have less. How do we do that? How do we change that? We have minus psi here. Yeah, we can do it. Logarithm of y minus y over alpha, right? Now, what do we need to do now? We know the CDF of eta, and we know the CDF. So we know the CDF. Sorry, we know that the derivative of the CDF is the PDF. So we need to find the derivative for this one and the derivative for this one, right? So the derivative of this is just the density of eta, and then the derivative of this is going to be minus the density of psi on this point times the derivative of this function here inside. So we are finding the derivative in respect to y. So the derivative is going to be 1 over 1 minus y. So minus 1 over 1 minus y, right? And here also alpha. And minus, so this is plus. So all we have to do is to write the density in terms of this point, on this point, right? So it means that this is equal to minus the density, and the density of psi is the density of the exponential distribution. So this is lambda e to the minus lambda psi, but we don't have psi. We have this point, right? Wait. Yeah, we have this point, so this is going to be minus ln 1 minus y over alpha times this, right? So over alpha y minus y.
Is it minus ln 1 minus y?
Hmm?
So it is the power of minus ln 1 minus y inside the bracket.
Yeah, y minus y, yes. Yeah. That's it. Well, we can reduce it, right, to something else, but this is the answer somehow, okay? And of course, we need to look at where this function is defined. So look, the exponential distribution is so in this case, psi is greater than 0, right? Then here the function is defined where? Is defined from 0 to, so psi belongs from 0 to plus infinity. So from here we can conclude that eta belongs from where? If we have plus infinity here, then what do we get here? We get 1. And if we have 0, then this is 1, so 1 minus 1, 0. So this is defined from 0 to 1. So the answer is that the function eta, the random variable eta, is from 0 to 1, and its density is this one. Well, you have your notes, so yes, you can use your notes. Totally. If you don't have in your notes what is, then I'm sorry, no, I'm not going to give it to you. Okay, now, is it so? Let's check. I think it's correct. Lambda over yeah, yeah, it's correct. We can reduce it and we will get the answer. Okay, now questions.
I think it's better if we switch it around. We solve the test in the lecture and do the test in the lecture.
Again? Did I get right what you said? Okay, more questions? It's everything that we did on class. So, like this is going to be on the test for sure. Any more questions? No? The process is very simple. Look, the process is like this. You have a random variable with some distribution. You have a function of this random variable. Then you have to find the CDF of this function. This is the CDF of that function, right? So this thing. You do it, you do it, you do it, until you get the original function here alone. Why? Because this is going to be the CDF of this function. Then you find the derivative of this and the derivative of this. And that is going to give you the density. And that's what you're looking for. So the answer, like I told before, is this, but do not forget to write this, by the way. I and y is between 0 and 1. So this is the complete answer, by the way, because this is true only if y belongs to 0 and 1. And that's it.
What does that mean? Why do you write that on your
Because it means that this is, so if y doesn't belong to this is 0. Yeah, I can write this, or I can write all of this again for y between 0 and 1, or 0 otherwise, right? It's exactly the same. So if you want, you can write it like this. You don't want to get confused. That's it? Okay. Do you have any questions there? So who is there? Gabriel? That's it?
No, Monica was here also, but for some reason the meeting ended and I just got back again. So I'm guessing she's trying to get back.
Yeah, by the way, you need to turn on your camera. I forgot to tell you that.
Okay. Like right now or when we start?
Well, we'll start in 2 minutes, in 1 minute. So yeah, right now. So look, I'm going to send you then to you and to Monica, and that's